In this class, we're going to cover situations where you have two separate groups. So this corresponds to quasi-experimental designs. The two groups aren't assigned randomly. So in the clinic, this may be because you're comparing subjects from two different clinics. This may be clients from last year versus this year. Whatever it is, you've got two groups of people and you want to make comparisons. Let's start with you've treated some clients, they're the intervention group that you're interested in, and you have another group of clients that got a different intervention, and they're your comparison group. It may, like I said, it may be that these two groups were at different clinics, they were different years, whatever it was, you have two different groups of clients. It wasn't a randomized controlled trial. How do you analyze the data? So you've measured each client after the intervention. So you don't have pre-intervention data, you just have post-intervention data. And your data is interval or ratio and normally distributed. So whose outcomes were better? So on this flow chart, you have post-intervention only. You don't have categorical data. So what we're asking for is, did the clients in the two groups have different outcomes? If you have interval or ratio data that is normally distributed, you're down here. So unpaired t-tests and confidence interval of the difference of the means. An unpaired t-test should be pretty familiar from biostats. So the null hypothesis for our analysis is going to be that the mean value for the intervention group outcomes is greater than or the target value. Now, depending on what kind of measure you're using, so if it's something like the Jebsen hand test, where lower numbers are better, you may be looking for the mean value of the intervention group is less than the target value. And the p-value we get from the unpaired t-test, that's the probability that we would have gotten these outcomes we observed if our null hypothesis was true. So the p-value is giving us the probability that the difference we expect to see isn't there. And so what you want to see is the mean for the intervention group exceeding the comparison group, if that's what you're looking for, or being less than the comparison group, if that's what you're looking for, and a p-value less than 0.05. Confidence interval for the difference of the means, your critical value is 0. So if there's no difference between the two groups, then the difference of the means will be 0. So if 0 is within the bounds of the confidence interval, then you can't eliminate the possibility that there is no difference with 95% probability. And when you're calculating this, you want to be careful and make sure you get the confidence interval for the difference of means from unpaired samples.